Good evening, students. My name is Abdul Bari. I welcome you all on behalf of ACE Academy. This is a revision session for SSC JE, the subject being fluid mechanics. And this is for both civil engineering as well as mechanical engineering. Let us get started with some questions. All the questions are relevant to your examination. Some of them are your previous examination questions only. Let us get started. Look at the first question. Pseudoplastic substances are non-Newtonian fluids for which? Now the question is mentioning pseudoplastic substances. What do we know regarding pseudoplastic fluid? First of all, it is a non-Newtonian fluid. We also know it is known as shear thinning fluid. Shear thinning fluid means tau is equal to m multiplied to du by dy whole power n, where the value of n is less than 1, greater than 0. This is a case of shear thinning fluids, that as the shear stress increases, resistance will decrease. Let us look at the relevant options over here. The question is saying dynamic viscosity decreases with time for which shearing force is applied. First of all, it is a time-independent fluid. So strictly speaking, you should not look for the variation with respect to time. Option B is saying dynamic viscosity increases with respect to time. So I will not choose any of these two options as my answer because this is mentioning time dependency. Moving further, dynamic viscosity decreases as the rate of shear increases. This is correct. Viscosity decreasing means what? Resistance also is decreasing. Option D is saying dynamic viscosity increases as the rate of shear increases. This is wrong. This option D would be correct provided it was dilatant fluid. So right now, pseudoplastic fluid we are having. The correct option over here is option C, dynamic viscosity decreases as the rate of shear increases. I hope this is clear to you. Let us move further. The density of water is maximum at what temperature? He has given you 4 options over here. This is a very commonly asked questions in interviews as well. Okay, 3 of the options are in degrees centigrade and 1 is in Kelvin over here. You should remember that density of water is maximum at 4 degrees centigrade. As a matter of fact, the graph of density versus temperature for water is given like this. This, let us say, is density. This is temperature. The graph is going to be like this. This is a graph. We are going to have maximum density at 4 degrees centigrade. This is 0 degrees centigrade. And this is beyond 4 degrees centigrade. So on either side of 4 degrees centigrade, the density is lesser. At 4 degrees centigrade, density is maximum. This is a very simple question. Let us move further. Now the question is asking, units and dimensions are particularly very important in examination. Guarantee you are going to find a few questions on units and dimensions. The question is saying 1 Stoke is equal to how much? If you remember, Stoke is the CGS unit of kinematic viscosity. The value of 1 Stoke is equal to 1 centimeter square per second, and that is equal to 10 power minus 4 meter square per second. This is the value. So the answer over here is 1 centimeter square per second. Option A would be the correct answer over here. I hope this is clear to all of you. Moving further to the next question. Now you see, this again is a question on units. 1 poise is equivalent to how much? Now 1 poise, this is the CGS unit of dynamic viscosity. If you remember dynamic viscosity, it is given by mu. The units of this thing are kg per meter second. This would be your SI unit. And CGS unit would be gram per centimeter second, which is equal to 10 power minus 1 Pascal second or kg per meter second. So this is your CGS unit. It is called as 1 poise. So gram per centimeter second. So option B would be the correct answer over here. Option B is correct answer. Moving further. The stress-strain relationship of Newtonian fluid is, what kind of relationship do we have? Strictly speaking, it should be rate of strain over here. But I remember this was the statement given in your examination. That is why I have taken directly the same name only. Strictly speaking, it should be rate of strain. rate of strain. This would be perfectly correct. But since SSC examination itself has given strain as a word over here, I have directly taken it as it is. Now, if you recall, the Newton's law of viscosity says tau is equal to mu into du by dy, power on either side being 1. So, tau power 1 is equal to mu into du by dy whole power 1. So, you're having a linear relationship over here. So, the correct answer is option C, linear relationship. Moving further. Look at this question now. This is a very simple numerical you are having. The question is saying the capillary rise at 20 degrees centigrade in a clean glass tube of 1 mm bore containing water is approximately equal to how much? Now 1 mm bore over here means what? It means the diameter is equal to 1 mm. That is equal to 10 power minus 3 meter. Okay. Sigma is given to you as how much? It is given to you as 0.0785 Newton per meter. I personally prefer to write everything in SI units, so later on it will be easy for me to get the answer. अब देखिए, the value of H is equal to how much? In a glass tube it is 4 sigma cos phi, where phi is your contact angle, divided by gamma times D. Now since we don't have a calculator, so what we'll do? We'll make small assumptions over here. Now first of all, cos phi, he has not given you anything regarding phi, so you can take in the case of water and glass tube, phi is equal to 0 degrees, so therefore cos phi will be equal to 1. So this is going to be equal to 4 into 0.0785 divided by gamma, I am going to assume is 10,000. Strictly speaking, it is 9,810. But I'm assuming this as 10,000. Diameter over here is equal to 10 power minus 3. So if you see this 10 power minus 3 and this 10 will get cancelled off over here. So this is going to become equal to how much? It is going to become equal to 4 into this much divided by 10. If you calculate 4 into 0.0785, it will be slightly more than 3. You can say it is slightly more than 0.3. Divided by 10 you are having over here. So this will become equal to approximately, nearly you can say 0.03 meter. This is equal to 0.03 meter approximately. So 0.03 meter is equal to how many mm? It is equal to 30 mm. The answer is going to be option D, 30 mm. Let us move further. Look at this question. Again a numerical, very simple numerical. The question is saying a Newtonian fluid fills the clearance between a shaft and a sleeve when a force of 0.9 kilonewton is applied to the shaft parallel to its sleeve. The shaft attains a speed of 1.25 centimeter per second. What will be the speed of the shaft if the force applied is 3 kilonewton? अब देखिए, the story is something like this. Imagine there is a shaft you are having. And there's a sleeve over here. Sleeve is sometimes also called as bearing. The sleeve is fixed in general. You're having this kind of an arrangement. In between, in the clearance present over here, we are having a lubricating oil. In this clearance, we are having a lubricating oil. And let us say there is a force that is applied over here, F. Now, interestingly, he has not given you the value of clearance, but that is not required also. If you see the value of force F will be equal to how much? If you observe, the value of force F will be equal to shear stress multiplied to shear area. Now, shear stress is equal to how much? It is equal to mu multiplied to du by dy multiplied to shear area. Now, what is du by dy over here? If you observe, you see this velocity, let us say, is equal to v, and this velocity by no slip condition is equal to 0, and the gap over here, let us say, is equal to t. So du by dy will be equal to v minus 0 divided by t. So that will be mu into V upon T multiplied to shear area. This is the value of force. Now if you observe over here, in this particular equation, mu is constant because we are not changing the fluid. The clearance is constant, therefore T is constant, shear area is constant. So this implies, I'm continuing over here, force is directly proportional to velocity. Force is directly proportional to velocity. Once you have established force is directly proportional to velocity, you can write over here F2 upon F1 is equal to V2 upon V1. Now if you observe over here, we want the value of V2. So V2 will be equal to V1 multiplied to F2 by F1. V1 is how much? 1.25 centimeter per second. F2 is equal to 3 kilonewton divided by 0.9 kilonewton. This is a value you are having. So this is going to be equal to 1.25 divided by 0.3, that is equal to 4 point, you can say 1.25 divided by 0.3 now. So it is approximately 4.1 something you will be having. If you observe over here the answer 4.1 something, option A is a relevant answer over here. If you observe, option A is having 4.16 centimeter per second. That is the correct answer over here. Okay, I hope this is clear to you. Fine. If you want, you can look at this particular slide once again, entire slide. Let us move further now. Now this is a question from your fluid statics. The question is saying, in case of rectangular lamina with side in liquid surface having a depth h, the depth of center of pressure will be how much? Okay. Now you see, he's saying, imagine that this is a fluid you are having. You are having a rectangular lamina such that one side is on the liquid surface. It is vertically kept over here. He has not mentioned any inclination, so I'm going to assume it is vertically kept over here. And one side is touching the liquid surface. In this case, the depth of center of pressure will be lying at what position? Probably some of you remember this directly. If you do not remember, draw the pressure distribution diagram or pressure prism diagram, you can imagine. It is going to be triangular in nature. If it is triangular, the centroid of this pressure distribution diagram is where the center of pressure is going to be lying. You should be knowing for a height h, the centroid will be lying at what distance? From the top, it will be lying at a distance of 2h by 3. This distance is supposed to be 2h by 3. So your center of pressure also will lie at a distance of how much? 2h by 3. This is something which you should better remember. Ideally, I would expect you to remember this thing. So the answer over here is option A, 2h by 3. Moving further, look at this question now. For a fluid at rest, okay, again it is corresponding to fluid statics. One advice I want to give you, it is not regarding this subject only, in any subject as such. Whenever you look at any question, okay, try to read it slowly so that you can deduce which topic, which subject this question is from. Okay, that is very important that you should deduce where is this question coming from. Okay, don't be in a hurry. When you're attempting any question, you should think that your entire paper is only that question. That is a very important skill, to disassociate with the rest of the paper and associate yourself only with that question at that moment. Let us read now. For a fluid at rest, let us look at the option. The shear stress is 0 only at horizontal plane. I'm having a problem with this word only. Shear stress throughout is supposed to be 0, whether it is a horizontal, vertical or inclined plane. The shear stress is maximum on a plane inclined 45, no. Shear stress depends upon, no. Shear stress is 0, it is correct. Fluid at rest, shear stress is supposed to be 0. This is basically leading to something called as Pascal's law also. Moving further. Pressure of 80 kilopascal is equivalent to head in meter of carbon tetrachloride of relative density 1.59 of value how much? See, the language of the question might not be very clear to you, but this is how the question was asked. So let me tell you what exactly this question is saying. This question is saying that if you are having a container in which you are putting in carbon tetrachloride, how much height of carbon tetrachloride what height of carbon tetrachloride is required so as to create a pressure of 80 kilopascal over here. Very simple. You can say pressure is equal to gamma times H. In other words, H is equal to pressure divided by gamma. Now pressure divided by gamma, what is pressure over here equal to? It is equal to 80 kilopascal divided by gamma is equal to. Ab dekhiye, since I do not have a calculator, I am going to make slight assumptions over here. Gamma is supposed to be 1.59 times gamma of water. Okay, gamma of water strictly speaking is 9.81, but I'll assume 10. And 1.59 I'll assume 1.6. So this will give me 16 kilonewton per meter cube. This value will come out to be exact to 5 meter. But if you see, this value I have taken greater than its actual value. Therefore, my answer should be slightly more than 5. And you can easily deduce which is your answer, which is your relevant answer over here. It should be option B, 5.13 meter. I hope it is clear. Let us move further. The total pressure force on a plane area is equal to area multiplied by intensity of pressure at the centroid if it is equal to area multiplied to the intensity of pressure at centroid. So area into pressure at centroid is how much? Gamma times h bar. अब देखिए force is equal to gamma area h bar is valid for any flat surface at any orientation. So now the answer should be if area is horizontal, vertical, inclined, in all three cases this is valid. So therefore the answer is option D over here. So option D is correct. In all three cases, this formula is going to be valid. Okay. Next question. For a submerged curved surface, now we are entering into curved surfaces. The vertical component of force due to static liquid is equal to how much? The vertical component of force is a weight equivalent thrust, gamma times volume. And the volume should always be measured from where? From zero pressure line up till the curved surface, whether or not the fluid is present. यानी कि अगर फ्लूइड हो या ना हो आपको उससे मतलब नहीं है. Whether or not the fluid is present does not matter to you at all. You are supposed to start measuring from zero pressure line up to the curved surface. So what is the answer over here? Weight of the liquid supported by the curved surface. ठीक है, it can be correct. Weight, the force of projection on the curves is not. Force of projection on projection is horizontal force. Area of curved surface multiplied to pressure at the surface. No, none of the answer. Relevant answer over here would be option A. Option A would be relevant answer over here. Moving further, look at this question. It's a question on hydraulic press. A hydraulic press has a ram of 20 centimeter diameter and a plunger of 3 centimeter diameter. It is used for lifting a weight of 30 kilonewton. Find the value of force required. This should be very simple. Without drawing a diagram, you should be in a position to recall what happens in the case of a hydraulic press. Now this diameter is equal to 3, he is saying. This diameter is equal to 20 centimeter, he is saying. And you have to lift over here a load which is equal to how much? 30 kilonewton. So you can say the pressure here and here both will be same. So you can say force to be applied upon pi by 4 into d square is 3 square must be equal to force on the plunger side is equal to how much? 30 kilonewton divided by pi by 4 multiplied to 20 square. This would be the answer. Pi by 4 cancel off over here. 3 square becomes 9. 9 times 30 is equal to 270 divided by 400. 270 divided by 400. Now 270 divided by 400 will be equal to how much? 2.7 divided by 4. 2.7 divided by 4 will be slightly less than 0.7 kilonewton. So 675 Newton is a perfect answer over here. I hope it is clear to all of you. A piece of metal of specific gravity 7 floats in mercury of specific gravity 13.6. What is the fraction of its volume under the mercury? Okay. So imagine you are having mercury over here. This is having S of body is equal to 7. S of fluid is equal to how much? It is equal to 13.6. What is the fraction of volume under mercury? That means this volume is being asked over here. How do we answer this? We can say by equilibrium, weight of the body is equal to force of buoyancy. Weight of the body is equal to how much? Gamma of body multiplied to volume of body. is equal to gamma of fluid multiplied to volume of fluid displaced. Now, the fraction of volume means volume of fluid displaced by volume of body is equal to how much he's asking. This will be equal to how much? It will be equal to gamma of body divided by gamma of fluid. That will also be equal to S of body by S of fluid. That is equal to how much? 7 divided by 13.6. Now imagine if it is 7 by 14, that answer would be 0.5. But it is slightly less than 14, so answer should be slightly more than 0.5. So the only correct answer over here, which is greater than 0.5, is 0.515. So option C would be a correct answer over here. I hope this is clear. Moving further. A piece weighing 3 kg in air is found to have a weight of 2.5 kg when submerged in water. Its specific gravity is how much? Technically, the language of the question again is having a mistake over here. Remember, you never weigh in kg, you weigh always in Newton. So he basically wants to mention these many kg force is what is he wants to mention. Anyway, let us get the answer over here. So we can say over here, apparent weight is equal to how much? It is equal to actual weight minus force of buoyancy. Actual weight minus force of buoyancy. So now apparent weight is equal to how much? 2.5 times g. Actual weight is equal to how much? Actual weight is equal to 3 times acceleration due to gravity. The question is asking specific gravity is equal to how much he's asking. Let us do one thing, let us take a ratio over here. Now weight by weight will be 1. Force of buoyancy by weight will be equal to S of fluid by S of body is equal to 2.5 upon 3 will be equal to 5 by 6. This implies SF by SB is equal to how much? This comes over here, that goes over there, 1 by 6. Now we know that since it is water, so SF is equal to 1 itself. So SB will become equal to 6. The answer over here is option D. 6 would be the correct answer over here. Okay? Let us move further. A block of ice floating over water in a vessel slowly melts. It's a very common question. What will happen to the water level? You see, whenever ice is melting into water, that time remember, this ice was equal to this much weight of water. So when it becomes water, it will occupy only this much of space only. If it is occupying only this much of space, therefore the level of water is neither going to rise up nor it is going to come down. The level of water remains as it was. So the answer over here will be remains constant. It remains constant. Moving further. For a floating body to be in stable equilibrium, where G is center of gravity, B is center of buoyancy, and M is meta-center, which of the following statements is true? Floating body stable equilibrium means what? Gm should be greater than 0. So G should lie, one second, I'm sorry. 1 minute please. 1 minute please. M should lie above G. Gm should be greater than 0 means metacentric height should be greater than 0. So G should be below, M should be above. Let us see what are the options given. M and B coincide, wrong. M is above G, correct. M is above G is correct. M and G coincide, M is below G, wrong. Option B is correct over here. Very common question. Moving further. Now we are entering into kinematics. The question is saying the flow rate is 1 meter cube per second in a pipe of radius 1 meter. The velocity of the fluid is approximately equal to how much? Please be careful, he has mentioned pi over here. So probably you don't have to use the value of pi. Get the answer in terms of pi only. So you can say discharge is equal to how much? Area times velocity. Discharge is equal to 1. Area is equal to how much? Pi times radius square. So 1 square into velocity. So answer over here for velocity will be equal to how much? 1 by pi meter per second. Option C would be correct. Very simple question. Moving further. Now he's asking something regarding continuity equation. The continuity equation in fluid flow states that energy along a streamline is constant. This is wrong. This is Bernoulli equation. States the energy is constant everywhere in the fluid, again wrong. Applies only to irrotational flow, no, not correct. States that net rate of inflow into small volume must be 0. Net rate of inflow into small volume must be 0. Strictly speaking, whatever influx is there, inflow is there, that same efflux must be there. That would be a correct statement. So this also is not perfectly correct. So this question, since it is saying continuity equation, he must mention it is law of conservation of mass actually. So instead of saying law of conservation of energy in both those cases, if you mention mass, it would be correct somewhere. Anyway, let's move further. Achha, one more thing, one very important thing. It is regarding the mega mock test. Okay. See, one good way of preparing for examination is to get a real feel of examination. Actual examination environment should be created. Okay, and a good way of doing that is by taking the mock examination, mock test. Okay, this mock test is being conducted on 26th May, as you can see over here. So you're having nearly 22 days from here onwards. The timing of the mock test is from 1 p.m. to 3 p.m. It is online examination for all these 3 branches, civil, mechanical and electrical branches. My personal recommendation will be, please go for a mock examination like this. The reason being, it will tell you where exactly you stand. You see, it's not just about knowing a subject, it is also about getting the feel of examination. Once you are in an environment of examination, your performance will be eventually better later on in real examination. Moving further, let us look at this question. Select the options that correctly match the items given in the list 1 to list 2. The options over here, list 1, rotational flow, irrotational flow, singularities, streamline spacing. Now rotational flow, irrotational flow will talk about vorticity. In the case of rotational flow, vorticity must exist. In the case of irrotational flow, vorticity must be 0. So A will go for 4, B will go for 3. A for 4, B for 3, ठीक है. So B and C can be neglected now. Singularities. When do we say singularity point is there? See, wherever the velocity components have become 0, at that particular point we can say singularity is there. ठीक है? So singularity point is velocity 0 or infinite. Streamline spacing. You should know one thing, that converging streamline means accelerated flow. So it means what? Less the streamline, more the velocity. Less the spacing, more the velocity. More the spacing, less the velocity you are going to have. So it is inversely proportional to the velocity. So C goes for 1 and D goes for 2. Correct answer is option A over here. Option A would be correct answer over here. Moving further. In case of two-dimensional flow, the components of velocity are given by u is equal to ax, v is equal to by. The point where no motion occurs is known as stagnation point. Moving further. Vorticity is how many times the value of angular velocity? Vorticity vector is twice the angular velocity. So the answer is 2 times. Moving further. Now let us take a numerical. Fluid flows through a converging nozzle with the exit diameter equal to half the entrance diameter. Assuming the ideal flow, if the velocity at the entrance is 2 meters per second, then the velocity at exit is equal to how much? Very simple question. You are having a nozzle. This diameter is d1, this diameter is d2, it is equal to d1 by 2. Okay, he is saying exit diameter is equal to half the entrance diameter, he is saying. The velocity at the entrance is equal to 2 meters per second. So V1 is equal to 2 meters per second. What is the value of V2, he is asking. Continuity equation says that A1 V1 is equal to A2 V2. So D1 square V1 is equal to D2 square V2. So V2 from here is equal to how much? V1 multiplied to how much? D1 by D2 whole square. Now D1 by D2 is equal to how much? D1 by D2 will be 2, 2 square 4. 4 times V1 is equal to 4 times 2, 8 will be the answer. Option C over here is correct. Very fundamental continuity equation question this is. Next question, in Lagrangian description of fluid field, is more computational. The Lagrangian description of fluid field, or flow field it should be rather, is more computational because more computational means it is more rigorous to calculate anything. It is required to track movement of large number of fluid particles with time. ठीक है, can be correct. Variation of velocity is expressed in Cartesian coordinate system. This is not a criteria. Velocity field is continuous function distribution of position and time. Velocity of a fluid particle is the same as a local velocity. See, the reason over here is you are choosing a single particle and observing. You have to do this for every particle. So it is required to track movement of large number of fluid particles. Many particles will have to be tracked in order to understand the motion. That's why option A would be correct over here. If a fluid mass is moving in a curved path with the help of some external torque, the flow is called as. You see, whenever you are having a vortex flow where external torque is there, it is called as forced vortex flow. If there is no external torque, it is called as free vortex flow. So since he is mentioning with some external torque, so we have to therefore take forced vortex flow as our answer. Moving further. For a forced vortex flow in an open tank, which of the following statements is correct? Again, we are coming back to forced vortex flow. The question is over here, if you observe, it is asking you regarding fall of liquid level at the center versus rise of liquid level at the ends. So imagine you are having a container in which you are having some fluid over here. You are creating a forced vortex flow, so you are having a paraboloid formed like this. So this height versus this height is being asked over here. You should know that whatever is a decline taking place over here, same is a rise going to take place over here. So decline and rise, both of them are going to be same. How do we get this idea? This idea is actually deduced from the idea that the volume of paraboloid is equal to half the volume of circumscribing cylinder. I hope you remember this thing. So therefore, whatever decline is there, same rise is going to be there. Which option will be correct? If you observe, fall of liquid level at the center is equal to rise of liquid level at the ends, option B over here will be correct. Option B will be correct. Let us move further to the next question. The question is saying the fluid forces considered in Navier-Stokes equation are. Which forces are considered in Navier-Stokes equation, he is saying. You see, Navier-Stokes equation talks about body forces or gravity force plus pressure force plus viscous force is equal to mass times acceleration. So three forces involved over here are body, pressure and viscous. In this case, the body force is given by gravity. So gravity, pressure and viscous, therefore option A over here would be correct. Option A would be correct over here. Moving further. A hot wire anemometer is used for the measurement of what? It is used for measurement of, first of all, it is not used for measurement of viscosity. It is used for measurement of velocity in the case of gases. Option B is correct. Remember, for pressure measurements, we are having devices like manometer. You are having devices like Borden gauge, transducer. So all these devices are present in the case of pressure measurement. For viscosity measurement, you are having viscometers like concentric cylinder viscometer. You are having Seybold viscometer and all. For velocity, you are having hot wire anemometer. You are having pitot tube, pitostatic tube. All these things are for velocity. And for discharge, you are having devices like your Venturi meter, Orifice meter, Nozzle meter, rotameter, elbow meter. All these devices are for measuring discharge. Now the question on Venturi meter, you can see over here. When Venturi meter is inclined, then for a given flow, it will show very, very important question. This question has appeared almost in every examination. As a matter of fact, it has also appeared in GATE examination for 2 marks. Generally, we assume GATE examination 2-mark questions are difficult, but this is a very fundamental easy question. Remember this thing, that if you are having any device which is measuring your velocity like Venturi meter, please excuse my diagram, it might not be as clear. It is creating a particular amount of flow. For a given amount of flow, you are having some reading over here. Let us say you are having some reading over here. You are having some reading over here. The question is saying that if this inclination is tilted, the angle is made different while the flow rate is being maintained, Q is being maintained, what would happen to this deflection level? Is this deflection going to change or is going to remain constant? The answer is, recall what the formula for Q is. The formula for Q is pi by 4 into d1 square d2 square upon root over of d1 power 4 minus d2 power 4 into root over of 2g times delta h star, or you can say hm into sm by z minus 1 and all. Nowhere in this formula theta is included. That means if I change the angle, all these values are constant, even Q is constant, so delta H star means this deflection also should remain constant. So nowhere in the formula of Q theta is present. So if you maintain the same discharge, the value of deflection, no matter whether you are changing the inclination or not, will remain same. So answer over here is same reading. Option C would be correct. Please remember this thing. You can expect this question again. It has appeared in many examinations. Moving further, in a series pipe application, series pipe, you are having two types of arrangements. One is series, other is parallel. I hope you remember in the case of series arrangement, the discharge everywhere is going to be same. The head loss is supposed to be added up. In the case of parallel, discharge is added up and the head loss is going to be same. The question is asking over here, head loss through each pipe is added to obtain the total head loss, correct? Head loss is same through each pipe, wrong. Friction factors assumed for each pipe to be same, probably here saying. Flow increases. No, flow increases in the case of parallel pipes. The correct answer over here is option A. The head loss through each pipe are added to obtain the net head loss. This is a very good question. The question is saying two small orifices A and B of diameters 1 centimeter and 2 centimeter respectively are placed on the side of a tank at the depth H1 and H2 below the open liquid surface. If the discharges through A and B are equal, then the ratio of H1 and H2 will be how much? Assume the value of coefficient of discharge is identical in both the cases. How do we answer this thing? Imagine कीजिए कि you are having a reservoir over here. This is the reservoir you are having. Let us say this is a level you are having. At this particular reservoir, you are having an orifice over here. You are having another orifice over here. Okay. He is saying the diameter of orifice A and B. Let us say this is 2 centimeter orifice. This is B. 2 centimeter orifice, and this is A. It is 1 centimeter orifice. Okay, this is equal to your H1. This is equal to your H2. H1 by H2 is equal to how much? Now, since CD is going to be same, I will assume CD is equal to 1 only. Better assume CD is equal to 1. So how do we answer this thing? I know the value of Q is equal to how much? Q is equal to area times velocity, or CD into area times velocity. So area is equal to how much? Pi by 4 into d square. Velocity is equal to root over of 2gh1, 2gh let us say. If you observe in this equation, CD is constant, pi by 4 constant, 2g constant. So I can say my discharge over here is proportional to how much? D square into root over of h. This is the value. Since discharge is same in both the cases, I can write over here d1 square root over of h1 must be equal to d2 square root over of h2. The question is asking over here h1 upon h2. I can say from here h1 upon h2 is equal to how much? It is equal to d2 upon d1 whole power 4. d2 is 2, d1 is 1, so 2 power 4, this is supposed to be equal to 16. The answer is 16:1. Option A would be a correct answer over here. I hope this is clear to all of you. You can see the working ones. Moving further, look at this question now. To avoid vaporization in the pipeline over the ridge is laid such that it is not more than. अब देखिए ridge, to avoid vaporization, basically cavitation is supposed to be avoided. So generally we take this value 2.4 meter above the hydraulic gradient line. The next question, अब देखिए this, one second, right. A jet of water issues from a nozzle with a velocity of 20 meter per second on a flat plate moving away from it at 10 meter per second. The cross section area is equal to 0.01 meter square. Density of water is 1000 kg per meter cube. Force developed on the plate is equal to how much? Now you should know the formula for force in this particular case is equal to how much? It is equal to force over here will be equal to rho into A into V minus U whole square, right? Rho into A into V minus U whole square. Rho over here is equal to 1000. Area over here is given as how much? It is given as 0.01. V over here is 20, U is 10. So 20 minus 10 is equal to 10, 10 square. 10 square 0.01 cancel off. The answer will be 1000 over here. Right? The answer is supposed to be 1 second. A jet of water is issued at 20 meter per second, flat plate 10 meter per second. It is moving away from it at this much, ठीक है? V minus U whole square. I'm assuming the options given over here are wrong. Otherwise, the answer is supposed to be 1000 only over here. Moving further. Look at this particular question. The question is saying, the force exerted by the jet on a fixed plate as shown in the figure below. Now this is in the case of inclined surface. How do we answer this question? You see, let us say the fluid is coming over here with certain velocity v, and this angle is given to us theta. So the value of force over here is equal to how much? Force is equal to, now you see m dot multiplied to velocity will give you the value of force. M dot is equal to rho a v, but the velocity that is striking normally over here will be equal to how much? This will be equal to v sine theta. This is the velocity striking normally. So you can say v sine theta over here. So therefore this will be equal to how much? Rho into a into v square multiplied to sine theta. This is the value of normal force acting. Okay, na? The force exerted by the jet on the fixed plate is equal to rho a into v square multiplied to sine theta. The answer is option B over here. Moving further. The discharge of a liquid of kinematic viscosity 4 into 10 power minus 2 meter square per second through 80 mm diameter pipe is 3200 pi into 10 power minus 4 meter square per second. What kind of flow do we have over here? He's asking. So we need the Reynolds number right now. Okay. So what we'll do is Reynolds number is equal to V into D by nu. Reynolds number is equal to V into D by nu. This is the value of Reynolds number we are having. Right now, nu is given to you, diameter is given to you, V is not given to you. We can also write V as V is equal to how much? Discharge upon area. Area is equal to how much? Pi by 4 into D square. Area is equal to pi by 4. Discharge upon area. One second. I'm sorry. Area is equal to pi by 4 multiplied to D square. Okay. This is the value of velocity multiplied to D divided by nu. This will be equal to how much? It will be equal to 4q upon pi times D multiplied to nu. This will be the value of Reynolds number. Let us put in the values now. We'll put everything in SI units. So we are having 4 into Q is equal to how much? 3200 pi multiplied to 10 power minus 4 divided by pi into diameter over here is equal to how much? Diameter is equal to 80 mm. That will be equal to 8 into 10 power minus 2 multiplied to nu is equal to 4 into 10 power minus 2. 4 into 10 power minus 2. This is the value we are having. Let us simplify this thing now. 10 power minus 2, 10 power minus 2, 10 power minus 4 cancel off. 4 times 8 is 32. So this makes 100 over here. 1 pi cancel off. The value we are getting is of Reynolds number is 400. 400 is well within the limits of laminar flow. The answer therefore is option A, laminar flow over here. Moving further. The question is saying fluid flow in a straight circular pipe is typically laminar in nature when the Reynolds number is. Now I have particularly taken this question and the next question for a reason. Dekhiye, let me mention this thing to you. Indian authors say the Reynolds number is less than or equal to 2000 for laminar. There are some foreign authors like Sengel is there, Frank M. White is there. Okay, those people say Reynolds number less than or equal to 2300 is laminar flow. Okay, so if you are not finding, first priority you give to 2000. If you are not finding 2000 anywhere, right now in this particular question, you are not finding 2000 anywhere, so therefore you go to the second priority, 2300. So for flow to be laminar, the Reynolds number must be less than 2000. Since 2000 is not there, I'll take 2300. This is also an SSC JEE question. Next question also is SSC JEE question. Now you see over here, laminar flow occurs in a pipe when Reynolds number is less than 2000. First priority we give to 2000. So remember, both these values are okay. Don't worry, they will not give you any question where both these numbers are present. If at all they give you, then give first priority to 2000. I hope it is clear to all of you. Moving further, look at this question. The head loss due to sudden contraction is equal to how much? In the case of sudden contraction, head loss is equal to, head loss due to contraction is equal to how much? It is equal to, if you remember, in the case, let us say this is V1, this is V2 over here. This is V2 over here. It is supposed to be equal to Vc minus V2 whole square divided by 2g, and all that thing will give you 1 by Cc, that formula will be there. But over here he is mentioning only one velocity. So he is expecting you to talk about sudden contraction from a reservoir into a pipe. Sudden contraction from a reservoir into a pipe. In this case, we say the value of head loss is equal to 0.5 V square by 2g. 0.5 V square by 2g. That 1 by Cc minus 1 whole square and all, everything will become 0.5 over here. So the answer is supposed to be 0.5 V square by 2g will be equal to, 1 second. There's a misprint over here. There should have been an option of 0.5 V square by 2g. Or V square by 4g. Since we are not having that, we will not choose anything from here. Probably there's a misprint over here. Chaliye. Hydraulic grade line for any flow system as compared to energy grade line. Where will hydraulic grade line lie? Remember, hydraulic grade line is V square by 2g below energy grade line. So it is always supposed to be below. It may match with energy grade line provided the velocity is equal to 0. So maybe below or above. It is below or matches with the EGL. Okay. So the best answer over here is below only. Look at this question. The question is saying crude oil of kinematic viscosity 2.25 Stokes flows through 20 cm diameter pipe at a flow rate of 1.5 liter per second. What kind of flow will we be having? Similar question we have done. Again, these kind of questions are very frequent, so I have taken again. Okay, we need Reynolds number. Reynolds number is equal to how much? Vd by nu. V is equal to Q upon area. Area is equal to pi by 4 into d square. Okay. So this is equal to 4 into, the value of Q over here is equal to how much? 1.5 liter per second. That is equal to 1.5 into 10 power minus 3. 1d cancel off over here. Okay. Divided by pi into 1 diameter. Diameter is equal to how much? 0.2 multiplied to nu is equal to how much? 2.25 stoke. That is 2.25 into 10 power minus 4 over here becomes 10 power 4. This is the value we are having. Okay. So this entire thing will make it 15. 15 times 4 is equal to 60. So you are having over here 60 divided by 2.25 into 0.2 pi will be equal to, this will be much less than 2000. So guaranteed it is less than 2000, we can say it is laminar only. Without calculation, you can say it will be less than 2000. It should be laminar. Chali, let us look at some questions now further. The question is saying the pressure drop for a relatively low Reynolds number flow is in a 600 mm 30 meter long pipeline is 70 kilopascal. What is the wall shear stress? The formula for wall shear stress tau naught is equal to how much? Delta P by L multiplied to capital R by 2. Delta P over here is 70 kilopascal. So 70 followed by 3 zeros. Length over here is equal to 30 meter. R over here. Now he's saying the diameter is 600 mm. That is 0.6 meter. So radius will be equal to 0.3 meter divided by 2. Okay. It is 700 divided by 2. That is equal to how much? 350 Pascal. Very high value. Answer is 350 Pascal over here. Moving further. The question is saying for a fully developed flow of water in a pipe having a diameter so and so, velocity so and so, kinematic viscosity so and so, the value of Darcy friction factor is equal to how much? So Reynolds number is equal to how much? It is equal to rho Vd by mu. Okay, or you can say it is equal to Vd by nu. Velocity is given as how much? It is given as 0.2. Diameter is equal to 0.1 divided by nu is equal to 10 power minus 5. So this will be equal to how much? This is coming out to be exactly 2000. Exactly 2000. If it is 2000, then you can use laminar flows formula, that is 64 by Re. 64 by 2000 will give you how much? It will give you 0.032. Option A would be correct over here. Moving further. The question is saying a fluid of kinematic viscosity 4 into 10 power. We have done similar questions, so I'll move further quickly because I'm losing time over here. Next question is the eddy viscosity for a turbulent flow. Eddy viscosity eta. Is it a property of fluid? No, it is not a property of fluid. It is defined only in order to get a similar kind of equation like Newton's law of viscosity. Okay? So it's a function of temperature only. This is wrong. It's a physical property of fluid. Wrong. It is dependent on flow. Correct. Okay. Because in turbulent flow it is going to come, but it is not going to come in laminar flow. So it is depending on the type of flow you are having. Depends on the flow. Option C would be correct over here. Moving further, shear velocity is what kind of quantity? It is a non-dimensional quantity. That is wrong. It is having dimensions of velocity. It's a fictitious quantity. Fictitious means imaginary. It is true. It's an imaginary quantity. Velocity of the fluid at the edge of laminar sublayer. No, it is not correct. So answer over here is it's a fictitious quantity. This again has appeared multiple times in many examinations. Moving further. Very good question. Which shear stress distribution is the correct one corresponding to the flow through a pipe of circular cross section with a parabolic velocity profile? That means laminar flow ke liye what kind of variation of shear stress is correct? I hope you remember this is true because we remember the formula for tau. Tau is equal to how much? Minus dp upon dx multiplied to r by 2. So tau is proportional to r power 1. Therefore, we are going to have option B as correct over here. Moving further, the question over here is saying, over a flat plate, the thickness of turbulent boundary layer at a distance x from the leading edge is proportional to, it should be is proportional to what? देखिए, this is very important. Delta is proportional to x power half in the case of laminar boundary layer. And delta is proportional to x power 4 by 5 in the case of turbulent boundary layer. Remember this thing. In the case of turbulent boundary layer, it is proportional to x power 4 by 5. So the correct answer over here will be option C. Moving further, look at this question. The question is saying match list 1 with list 2 correct answers. Again, you are having many times questions coming from dimensional analysis also, or dimensions of some quantities. Dynamic viscosity. What is the code for dynamic viscosity? Dynamic viscosity is kg per meter second. So ml power minus 1 t power minus 1. This is correct for dynamic viscosity. If you observe over here, ml power minus 1 t power minus 1 is 3. So A will go with 3. The moment you see A is going with 3, you eliminate these two options. These are wrong options. Okay. Moment of momentum is going to give you torque. Torque is equal to force multiplied to length. Force is Newton, kg meter per second square. So it is ml t power minus 2 is force into length is ml square t power minus 2. ml square t power minus 2 means B will go for 4. So B will go for 4 over here. Now if you see, option B also is wrong over here. The only answer that is correct is option D. This is the advantage of having matched the following questions. You don't have to solve everything. Without solving everything also you can get the answer if you are smart enough. Still, let us complete this thing. Power is equal to force into velocity. So it is m L t power minus 2 is force. Velocity is equal to L t power minus 1. So it should be ml square t power minus 3. There should be a minus over here. Printing mistake, I'm sorry. There should be a minus over here. So C will go with 1. Bulk modulus of elasticity or volume modulus of elasticity. It will have the units of Pascal only, Newton per meter square. Okay. Remember, every modulus of elasticity is going to be pressure or stress units. So this is going to be equal to how much? ml t power minus 2 divided by length square. So ml power minus 1 t power minus 2. This will go with 2. D will go with 2. The code is 3412. 3412 over here is correct. Okay. With this, I close the questions on the subject of fluid mechanics. I hope these questions were clear to all of you, and I wish the very best on behalf of the academy to all of you. Okay. Again, I am recommending you, please take the mock examination. It will guarantee benefit you in some way or the other, at least time management, or it will help you understand which questions to attempt first. Okay, the planning of examination comes only by attempting mock papers. No matter how much ever you study, the plan of examination is only understood by mock examinations. Thank you.